As adults, when we see things like $21.37, we really don't think that much about how sophisticated this idea of a decimal point and what it all kind of really means. But it is a good way to start talking about decimals because children do see prices of things and things like this. So sometimes I'll say, okay, $21.37. Let's say I'm living in a world where, oops. So I like to say, what if there's a world where the only money units there are $10 bills, $1 bills, there's no $5 bills, there's no quarters, there's dimes, there's no nickels, so there's pennies. And what if those are the only 4 units of currency? Well, to do $20.37, we knew we'd need exactly 2 $10 bills and one $1 bill. And the 37 cents, since there's no quarters, the only way to make 30 cents is 3 dimes and 7 pennies. So this kind of simplified world where there's only these 4 units of currency gives you an idea that the 3 represents 3 dimes and the 7 represents 7 pennies. More things about decimals. Some people like to do like a number line. 0, 1. You know, we see like in a ruler, we're used to seeing in a ruler you have like halves and quarters, but you could show that you could have a ruler like one that's like metric system. Instead of having halves and quarters for half inches, quarter inches, they have 9 lines in between. And these represent tenths, 1/10 of 1 unit. So the idea that 0.5, you say, okay, there's 1 and there's 2, and in between 1 and 2 is 1.5. It is pretty sophisticated, this whole 0.5, but some people just say, oh, people get a feeling for it even before they really have a good understanding of it, that 1.5 is the same thing as 1.5. I think about it, when a small child, when you take their temperature and you say, your temperature is 98.6 degrees, and then, oh, you're a little bit warm, you're 98.9 degrees. So that idea that there's like this extra number at the end, which tells me that I'm like between 98 and 99 and getting closer to 99. But it is, again, a pretty sophisticated concept, so it's no surprise that it's not like an easy thing for kids to get a feel for. Back to here, 1.5 is in between 1 and 2, but 1.6 is a little closer to 2, and 1.4 is a little bit closer to 1. Decimals used to be called decimal fractions because they were shorthand ways. 0.1 was a shorthand way of saying 1/10. And 0.01 is a shorthand way of saying 1/100th. And when we go back to our money thing, 21.37, well, nowadays adults say 21.37, but they teach kids to read this as 21, and then they say, and this is 37 hundredths. I personally don't. I like to think of the 3 as 3/10, and the 7 as 7 hundredths. It is true that you could think of this as 37 hundredths also, and that's how they teach kids to read it. I don't think it's worth making such a big deal about reading that number as 23 and 37 hundredths. because in the real world, people say 21.37, and they understand. It's kind of confusing that 21.37 versus 21.4. A student can get confused that 4 is less than 37, yet 21.4 is bigger than 21.37. I'm just telling you this as a thing to just think about. It's definitely confusing. Why is it? Well, this is 4/10, and this is 3/10. This is between 3/10 and 4/10 because it's got an extra thing at the end. We often tell people to just make them so they end at the same place, 21 and 40 hundredths versus 21 and 37 hundredths. But decimals are kind of confusing in that way. It's not enough to say, oh, well, it's like a generalization, 21, or for something like 521. Sorry about that pause. Something like 521, each place is 1/10 of the amount of the one before. But it is kind of strange, like 1/10 of one, these are these smaller units. Anyway, it's a sophisticated idea, but on the other hand, when you see like a ruler, and you see that they're split up, or something like this, that the tenths are just in between 2 and 3, and the hundredths, well, you'd have to, between 2 and 2.1, there would be 10 other tiny lines. So it is hard to visualize these tiny units. So things that people should be able to do with decimals is to compare them. I said before, comparing this versus this, and knowing that 21.4 is bigger because it's got 4/10, and the other one's only got 3/10 and a little bit more. Another thing is rounding. The idea that 21.5, or let's say 21.6, rounded to the nearest integer is 22. Visually, 21.6 is here. It's closer to 22. A little arbitrary that 21.5 also rounds to 22, even though it's sort of halfway between them. But that is sort of an agreed upon thing that we round up. You might think it's not fair to round up. What about 21? That's not fair to 21. 21.5 is halfway between there also. Well, it's okay because 20.5 rounded up to 21. So 21 did get its chance to get rounded to also. So comparing, rounding. And then the arithmetic, adding, the fact that 0.2 plus 0.3 is 0.5, and 0.2 plus 0.8. It's confusing, actually. It's not 0.10, although it wouldn't be crazy if it was, but it's actually 1.0. So you say, well, that's, visually speaking, this is 2/10 and 8/10, which is 10/10. So I expect that to be the same thing as 1. But it is a little hard to visualize. But if we do standard algorithm, for adding, we so-called line up the decimal point. And when we carry the 1, we put it there, and the decimal goes there also, in the same place as these are. And subtracting is just like adding. 1.4 minus 0.8. You line up the decimals. And then you have to do the borrowing. You kind of ignore the decimal point. And you just kind of have it lined up for adding and subtracting. Multiplying can be pretty confusing. But if you know that like 0.1 is the same thing as 1/10, then like 50 times 0.1 is the same thing as 50 times 1/10, so it should be 5. The standard algorithm for multiplying is not to line up the decimals, but just to kind of ignore the decimals. You get 50 as your answer, but then the decimal goes over here, and it does become 5. The idea is that 50 times 0.1 is the same thing as 50 times 1 times 1/10. So you kind of do the 50 times 1. But when you multiply something by 1/10, in general, like 7,520 times 1/10, the 7,000 turns into 700, the 500 turns into 50, the 20 turns into 2, and the 0 stays as 0. That's why multiplying by 1/10 does, as they say, move the decimal over 1. So if you want to take 752 and multiply that by 1/10, it becomes 75.2. The 700 becomes 70, the 50 becomes 5, and the 2 times 1/10 becomes 2/10. So we say 72 times 0.1 is 75.2. The so-called decimal at the end moves over 1 to the left. And in general, if I do 72 times 0.01, that multiplies everything by 1/100th. So the 700 becomes a 7. The 50, 1/10 of 50 is 5, so 1/100th of 50 is 0.5. It's a 10th of a 10th. And 100th of 2 is 0.02. So multiplying by 0.01 moves the decimal over, as they say, 2 places. And this rule can generalize. And even if I have something like that, this decimal moves over 2 places, so you get 5.2376. Once you get the general idea, you don't have to visualize everything that's going on. Once you believe that multiplying by 0.1 moves the decimal over once, and multiplying by 0.01 moves the decimal over twice, then you can kind of expect that it's going to always work. So if I do 752 times 0.03, well, that's not just moving the decimal over. So we do 752, basically we think of it as 752 times 3 times 0.01. So we do 752 times 3 first. 6, 15. But it wasn't 752 times, well, that was 752 times 3. But we also, don't forget about the 0.01. That moves the decimal over twice to get 22.56. The official way of doing this question, though, is to line up the last digit and multiply like you regularly would, and then you count how many decimal places were there. To multiply a decimal by a decimal, like 1.5 times 0.3, it's kind of like 15 times 3, but it's 15 times 0.1 times 3 times 0.1, which is like 15 times 3 times 0.1 times 0.1. So these happen to be lined up. They don't need to be, though. We get 45. And then each of these 0.1s moves the decimal over 1, so we get 0.45. Notice that's also what you would get if you counted how many times, if you take this decimal and see how many places did you have to move to get to that spot in the question, combined, 1 for each. That's also what happens in the answer. Anyway, these decimals are pretty sophisticated. When you divide 1.5 divided by 0.1, well, the answer is 15. If I just were to subtract 0.1 over and over, it would take 15 times to get down to 0. When you divide by 0.1, the decimal actually goes to the right instead of to the left. And dividing by 0.01 becomes 150, because there would be so many of these tiny 0.01s. Like, think of it this way: $1.50, how many pennies is that? Well, it's 150. And $1.50, how many dimes is that? Well, it's just 15. Something interesting about division: if you do 8 divided by 2, you get 4, of course. If you do 80 divided by 20, you also get 4. If you multiply each of these things by the same amount, the number of 2's that fit into 8 is the same as the number of 20's that fit into 80. And if you multiply them each by 7 or something, 56 divided by 14 will also be 4. If I take 8 times 7, everything's kind of growing. These guys each grow the same amount, so the number that fit in is equivalent. Well, when you divide decimals, like 2.5 divided by 0.05, for instance, the trick is, if you times both sides by 10, you get the same answer. And if I times both sides by 10 again, you also get the same answer. But we don't have decimals anymore. So the general trick for dividing decimals is you see which decimal has the most numbers after it. This one has 2, this other one has just 1. And we move the decimal, as we say, 2 places, and we move this decimal the same amount. We have to put a 0 there. And we do 5 into 250. And we get the answer to the original question. But you do see a lot, that thing about moving the decimal over. People memorize it. But have they spent some time, like, thinking about, if 8 divided by 2 is 4, why is it not surprising that 16 divided by 4 is also 4, or that 24 divided by 6 is also 4, or that 80 divided by 20 is also 4. That's why this whole, you can move the decimal over. Otherwise, people are like, why am I allowed to just move the decimal over? Okay, well, that's a general review of decimals, just to give you a feel, because in 4th grade, students start learning decimals. And I do think, money is a good thing to think about, to understand the idea of tenths and hundredths, and temperature. A lot of kids have known, when you say, oh my God, you have 100.3, well, usually just do tenths for temperature, but they understand that that's bigger than 100, and that 100.9 is like worse. And then, oh no, I'm now at 101. Well, it was a little bigger than 100.9. Visualizing with a number line, how it's cut into tenths now, and each of the tenths is cut into hundredths. Anyway, decimals can be quite a confusing thing, but in this video I wanted to show you about rounding, comparing decimals, adding, subtracting, multiplying, dividing, and giving you some rationale behind the mysterious divide by moving the decimals over, and multiply by ignoring the decimals and just multiplying and then putting the decimals in. Anyway, that's what I wanted to show you about decimals. I think the next video I'll talk about ratios and percent.